second project, which may start after spring break. I never seen such a fast delivery at UB. So last week I ordered, I request to the department. Then the day after I received all the items. So this is the toy car that we are going to use. It's a smart video car kit, the version 2 with the Raspberry Pi. So we are going to use this one for the autonomous vehicle, the project with the data mining, mostly machine learning technique. So over the weekend, I tested one of them. Right now, the GitHub and me work together to prepare your project because we do not have enough time to cover the all computer vision or the autonomous vehicle, and only focus on the data mining project. So we try to provide all the ready to go the autonomous car. Then you are going to add the problem. So this is the one example. So this is actually live stream from the car at my office. Okay, so you can see the black is the pretending the lane. So I put the tape, the tape, and on the floor. Then the red one is the detected the lane. So using the very basic lane detection. So so right now it's not the autonomous. It's not auto the steering yet. So it's a manual. So right now using keyboard I can control. You can see the moving forward. So still detect the lane. That's the red one. So everything is going well. So hopefully maybe next week I'm going to add autonomous, the auto piloting, auto steering. So then using this one, you are going to add at least one the problem based on the data mining or the machine learning technique, like the traffic light detection, it's based on the training, and also or the stop sign, and what else? Pedestrian or the intersection, and we can design the several problems. So you are going to add. So at the end of the semester, based on the demonstration, you will be graded. If everything is going well, detect and stop and going well, then you will get the A. Otherwise, based on that. So it will be fun, the last project, okay? But to save your time and our time, the GA and GitHub and me will provide the ready to start the autonomous vehicle, the kit for data mining. Okay, so the main problem is first we have only 5 the kit. So I'm going to form 5 teams. So not the 17 right now. So then each team will work together. But you may not use a lot the car itself for testing. Mostly you can use the Python or the programming, the environment, then you can test with the car the certain time. And another problem is this, it's not very reliable. It's easily broken. It's a toy. It's just $100 toy. It's a really fragile. So that's another thing. And also this is not the robotics class, this is not computer vision class, this is not the autonomous vehicle class, it's a data mining class. So we do not have enough time to cover each and every detail. But if you have the experience, that will be really helpful. For example, if you know the PID control, then it's definitely helpful for the auto steering and something like that. Okay, that is the second project will be ready probably the beginning of March. That we'll announce. So, any question regarding to this one? And also the controlling is not very precise. So I try to go straight. As you can see, it's not going straight. bad word. Moving, if something happen. This is my office. So, but yeah, it's live. So, but lane detection is I think considering number of code is pretty much okay. You can see the left lane is moving because I did this because it's shiny. So edge detector is not working correctly. Okay, so let's start. And the first project. So far we had, I moved the one team who create the student group by yourself. So there, do not use this one. I no way to remove this student group. We are going to use the project group for the first project. So then the team number 5 is okay, but we have 2 more students, Harsh Kumar, here, and the Shiva. So you are not assigned yet. Okay. So let's see. We have the 2 teams. So project 6, Pupan here today, not yet. Amar are here. So can you work together with Shiva? Yeah. Okay. So I'm going to assign them. That make me easy to finalize the project team. So Shiva add to the project 6, the group 6. Then the Harsh Kumar go to the 7, right? Then I'm going to remove the 8. Okay, so finally we have the 17th. So the due date of the phase 1 is this Friday. So phase 1 is the brainstorming. So it doesn't require any the knowledge. So this is a kind of the dilemma. So if we covered all the topic to start your project, it will be probably end of semester. Even by the end of semester, we cannot finish all our lecture. So no way to wait until we cover everything. So anyway, so we'd like to start, which means when you are doing the brainstorming, so you need the time to research what's going on, the Kaggle, and what's going on in the data analytics or data mining or machine learning and so on. Please research. Mostly you are going to use the Google, but please spend a little bit of time to what's going on in this area. Then get together and bring your idea, then decide which the project you are able to finish in this semester. Also check the Kaggle whether you have the similar project or you can directly find the project from the Kaggle. So not only just the active project, but it can be archived. So finish it, it's totally fine. Okay, some of the projects are well-known projects. When Kaggle starts, they put a lot of the sample, the project, and the promote the company or instructor and university to put their project. So please do not select the obvious project or well-known project. They already have a bunch of solutions, so it doesn't help you, and it's a waste of your time and waste of my time. So interesting but doable project. Then you don't have to write anything right now. Just prepare 2 or 3 pages the presentation file. So in the next class, probably next class, February 20. So next week, Wednesday. So we are going to have the short presentation for each team. So it's not formal presentation, just I'd like to see what you guys are doing, and if that makes sense, then it will be approved. Otherwise, I'm going to ask to revise or select another project. But at that time, it will be a good idea what is your project and what is the problem. Sample the data. So data is also important in your project. So then you can start your project after the first phase. So first phase doesn't require a lot of time to write something. It's just find. It will be a good idea to think about the backup plan. So if you have the 2 or 3 candidate project, it is also fine. Okay, but each team may have So we have 7 teams, so probably around the 5 minutes the short presentation. Yes.
Do we get Google Cloud credits for this stuff?
Unfortunately, this semester not, but if you guys want, I can request to get the credit. Do you need?
Well, what if our computers are not powerful enough?
Okay, then I'm going to request. It's not a big deal. Okay. So, but I'm not going to use this time the GCP for the data mining. But if you want to use the Google Cloud for the computing power or the API, so also you can use some of the API provided by the machine learning library on the Google. So you guys can use it. So I'm going to let you know. So it'll take 2 or 3 days to get the credit. Okay. Any other questions? Okay, so that is the project. We finalized the project team, so it's ready to go. And what else? Today we are going to have the first exercise lab. So your laptop should have at least a Python. But if you have, I recommend the Python 3.6 because the TensorFlow is not comparable with the newest version, latest version, 0.7. However, if you already installed the 0.7, it's fine. The exercise. Today we are going to just start. So we are not going to use the TensorFlow. We are not going to use any deep learning until probably the next 3 weeks. So we will use just if you have the Python, it's totally fine. Okay. If you are using the MacBook, so please install the 3.7 or Python 3 because the 2 is already built in, but not a lot of problem, but still not. So we are going to use the Python 3, Python the 6 or 5. 5 is also fine. Okay? And please install the pip. Also, from time to time, if package is required, we need to install using pip. So if you do not know what is a pip, search the Google. Okay. So any questions? So we will have the exercise at the end of class, probably the 7:30 or 7:40. We will start. So that is the exercise lab project 2. Then we are going to. What I'm thinking is we missed the second week class. So next. Actually, you're supposed to discuss about the frequent mining, association rule mining, but nowadays association rule mining is a part of the recommendation system. It's very similar, so I'm not going to spend a lot of time for the association rule mining. Instead, probably at the end of the semester, we will have a time to talk about the social media data mining. At the time, I will introduce about the association rule mining based on the recommendation system. But next week I will spend maybe less than 20 minutes to idea of the association rule mining. So it's also part of the it was used frequently before, but nowadays it's a part of other the data mining techniques. Okay. Any other questions? That's good. So this is a data mining class, which means we are dealing with data. So it is obviously very important to know about the data. Actually, data is everything. When we are playing with the computer, because computer, as I introduced the beginning of semester, the first week. So computer is not that smart, so it's understanding only the structured data. So data. So the data mining, deep learning, whatever. So any algorithm, any technique, or any process are dealing with such a data. So it is very important to know about such a data. So in this chapter, we will see the types of data and what we can do. So especially I'd like to introduce the data visualization. So nowadays the data visualization can be considered a part of data analytics. So it's a part of the data mining. So only using the data visualization, we can understand, we can find the meaningful information, which is the main purpose of the data mining. So data visualization nowadays is very important. So, and all the topic that we are going to discuss today will be the kind of the fundamental of the other data mining and machine learning techniques. So it's very important to understand. There are different types of data. So mostly the data is, think about when you learn the program language, what is the most important part? So what are you focusing on when you learn the new program language?
Syntax.
Syntax? For me, first, obviously, whether there exists a hello world. So the Java is a hello world, and also C also hello world. What about Python? Python is one of the simplest program languages for hello world. One line, print, hello world. So this is the first thing you need to check. Then, sometimes, after you finish hello world, you are all set. So, especially data, the database language like the SQL. So a lot of students just select from where, then that's it. So that is kind of hello world side, the segment in the SQL. But in addition to that, in my case, so somebody said, is it easy to teach computer science? The teaching computer science itself is not a big deal. The problem is, so every day is changing. So good news, the database is not changing a lot. It's still the relational database, but program language, when I learned the computer first time, it's a Fortran, COBOL, and so on. But right after that, the C languages, C++, and the Java, and right now the CS11, 102, maybe changing into Python. A lot of universities use Python for the introductory computing class. But when I learned the computer program, the new program language, first I'd like to see data type. Sometimes there are a bunch of different data type. Mostly, when program language define the data type, they try to save memory space. Okay, like they are using different data type for integer and float. Why? If we use a float for the integer, a lot of computation and the bigger the memory space. Because of that, we are using the integer whole number separately. It's like what kind of the data type, especially numeric data type and character data type. Because computer actually cannot understand the character itself, as you know. Instead, it's just a number. Then using ASCII code, we can represent the character or symbol. Nowadays, even the emoticon. So emoticon is a part of such the Unicode standard. So, but it's a number and the character are different. So, for example, the C language, the no way to represent the character. Instead, you need to use the pointer array. Something like that. That is the first difficult thing. And Java uses the string class, not primitive data type. For the primitive data type, only the one character, like that. What about the Python? So you can take a look at how the program language define the number and the character. Then the most of the thing will be covered. Not much use the very complicated, rarely use the data type. So mostly number. How can we represent the number? How can we represent the character? Then another thing is, syntax is too much syntax. Instead, I'd like to take a look at control statement. If I know the if then else, then that's it. So I can implement the for loop, while loop, the do while, the using if control statement. It takes long, it will take longer than such a thing, but if you know how to control the statement, then pretty much. So 90% of the computer coding will be done. So I usually take a look at. That means, so when we define the class has the data and operation. So data is most important part. So basically, so as I mentioned, the data has the numeric data a lot. So most of the students for the first project will take a look at such a text or the numeric the data, the numeric type-based data set you are looking for. Some of the team may be interested in the video and the image, but it's interesting, but if you do not have the background, it will be hard. How am I going to start for the classification of image? It looks fun or attractive, or it's really sexy to classify this image, but it will be hard. That is true because comparing to the alphanumeric data, especially numeric data, it's much more complicated data structure. So it is very important that when we start the data analysis, understanding data itself, even the number itself, the data itself, some of the data is 1, 2, 3, there is an order. Sometimes no order. So dealing with such ordered set or non-ordered set are different. Also, each number may represent something class or the class or the category. Such a categorical data may be different. Also, we may consider the interval, okay, or continuous data or the discrete data. Even though it's just number, depending on the meaning of such a data, we need to handle differently. So in this chapter, we'd like to see can you see clearly? What types of data we have and to the. This is better. Yeah. Okay. So we will see. So I'm going to little bit speed up because you already know the many of such a concept. Okay, so you have seen when I learned the data mining first time, the most important part of the data mining is to define the record. So in data mining, the record can be usually we use the terminology of the record in database. In the database, we call the tuple or record. It's a data. But in data mining, we prefer to use item. So number of item, but it doesn't matter. So whatever the terminology you use is the same meaning. Okay? So it can be called the record, one data. Or it can be called the item, it's one data, one row. Okay? So we have such a record data. So such a data has the alphanumeric data. Also, sometimes it can be represented by number of attributes, especially it's a formalized, standardized, or the modeled such a data. Like if we are using relational database model, so each data has the number of attributes, something like that. So that is a record, that is an item. Mostly in data mining, we use such a number of attributes. Later, we will see the two handles. It's very important to analyze or to understand each attribute, whether that attribute are related or not. Also, number of attributes. So as I mentioned the last class, so if we have really too many attributes, which means sometimes it's called a dimension. It's a high dimensional data. When we have such high dimensional data, we have a curse of dimensional. Curse of dimension. So that is the record. Also, data may be the graph structure. So it is very important nowadays because of social media data. Social media, like Facebook, Twitter, and others, the Instagram, and so on. So what is the most important part of the social media data? Social media website, social media site. What is the most important thing? Relationship, which means connection. Okay? I'm not sure whether I mentioned here. So one of the important characteristics of the Homo sapiens is social animal. So without interacting with others, cannot survive. Maybe sometimes, some of them, like me, I'm really isolated from my old community. So after I moved to United States, but it's okay nowadays because I can communicate with my friend through using the Facebook and so on. In such a Facebook or Twitter, such a social media site, most important part is the network connection. Because of that, so I think the most important feature of the Facebook is like. Okay, no matter what the service that the Zuckerberg provide, most important part is like. Using like, we can make the strong connection, or anyway we can keep the friendship like that. Because of that, even the Zuckerberg, I believe the Facebook knows such a privacy issue or security issue, everything, but they cannot make it stronger, because if they had a very strong, very strict privacy and security policy, if they apply, probably they lose a lot of such a connection. So because of this kind of the juggling, so how much whether or not. So that is the social media side. By the way, then problem is in the computer perspective. How can we keep the connection or the connected like such a relationship in our computer data structure? At that time, we are using nowadays graph network to graph the data structure. So we will see at the end of the semester the social media data mining based on the graph. Then the sum of the data are ordered. It's a sequence. So it's also important nowadays. The sequence data are everywhere. If you need to select the most important sequence data, what will be? Yes, that's what I liked. That's my answer. Stock. If you can analyze the stock market, for example, Google price is like this one or down. So can I predict gain or loss tomorrow? So I don't have to teach here. I can use that. So it's very hard. It's a still open problem. One, to analyze the stock price. Can we predict? Which means almost a random one. So if everything is going well, so everybody predict this gain tomorrow, but if Trump tweet, then it may be done. So how can we predict whether Trump will tweet or not? So it's a kind of random. Such an economy and especially the stock price is affected by too many factors. It's not just too many, it's randomly that happen. But still, there are a lot of research. You can find really a lot. So prediction model of such a stuff. Some of I know the professors spend in all their life to make the model, really model of such the economic price or to predict such a thing. Then they apply. If they have break the even, like even the 0.1% guarantee, it will be super rich, right? So that is one of the example of the sequence data. Not only stock, but any data based on the time, along the time. It is a sequential data, ordered data. Video, definitely. So what is the video? That probably we will use the video data for the second project, because we are going to use a live stream, as you have seen just before, from the camera. So what is the video? It's nothing but set sequence of images. Long time ago program. I'm not sure your generation, not my generation, not much different from your generation. So if you have can I borrow the note? So when I was kid, I draw the arrow or the paper simply, and next page, and we can make the moving picture. That is the name of the video. That is the video. It's a sequence of imaging. So when we deal with the video, there are a lot of research. So when I was a student, we tried to find the first video is too big at the time. So we need to find a way to keep the video data in the computer and feed to the network. So compression was important. So we try to compress without losing the, we may lose, but with less the losing the information, we try to transfer the or send or receive or process. So the output of such a compression is for audio MP3. So MP3 is pretty much done. We cannot make better the audio quality than the MP3. That is the reason you may not see the after MP3 regarding to the audio. Or the iPhone or iPad, any the player, so MP3 is enough. But sometimes it may be different, but the quality is not much different. But video is different. Video is a lot the different, the standard and compression. What is the idea? How many images per second nowadays? So you are watching, I'm still watching the SD quality. So HD, high definition, it has 60 to 128 images per second. The human eye cannot recognize that. Okay. Somebody said in the marketing, so they can put the image between the frame, which cannot be visible, but in your the perception, in your the brain, but I don't know whether that's true or not. But anyway, the HD quality 120, which means the next image is not much different from the previous image, which is called the frame. Then, if it's not much different, we need to keep all the information. We don't have to only change it, slightly change it, the data. So that's the idea of the compression and the video. That was the main problem when I was a student. Nowadays, if you watch the YouTube, if you search the YouTube, even automatic annotation. So like from you. So when I try to watch the YouTube, I try to search the video for the cat. So if you type the cat, it's in search of the YouTube. How does the YouTube search the video related to the cat? Previous approach, they search the title of the video or description of your video. Nowadays, they actually search the contents of video. So the current technology actually analyzes such a video data for automatic annotation. Not just annotation, they actually respond. So if you ask something question like the chatbot, so every day some of you guys are lonely, so you talk to the Alexa or Google Home, right, or Siri. So similarly, video can be the response based on such an automatic annotation. Also, the reverse from the video, so it can automatically summarize the video with the text. Right? That doesn't mean it's not only the recognizing object, but flow of that object. So they understanding such a flow. That's the current technology. So such a annotate, but it's not really the difficult or the impossible problem, because think about when in this is similar as the format of the video. The next frame is not much different. So it's not the suddenly change it. Any action or contents of video, if something happens, everybody can predict the next scene or next shot. So when you watch the drama, so pretty much you imagine probably next will be they are fighting, and probably next they get along with, something like that. You can imagine. So because there are kind of plot, standard plot. One thing happened, then followed by another one and another one. If you pick up the phone, you will not yell or something other. Probably hello, like that. So kind of such a pattern. So we can find such a pattern from the time series, order data. So nowadays, such order data important. In deep learning, we use such a characteristic of the data. So like for example, the recurrent, the neural network recurrent means is if something happens, probably next will be followed. We try to find such a pattern along the sequence time. So that is another. And spatial image multimedia data, as I mentioned, so this is nowadays not only just the alphanumeric data, we have focused on this part in our traditional computer science subject, but nowadays it's getting wide the data type. Actually, the major was this one in my PhD dissertation, believe it or not. My supervisor was one of the first, the professor researcher who tried to use the data mining technique for video. So my dissertation topic is applying the data mining technique among the data mining technique clustering, the algorithm for indexing of the video sequence. So I used the surveillance camera. In the surveillance camera, so in the classroom, if you can easily imagine I'd like to keep the trajectory of moving object, for example, student. And how many different types of the moving object? Actually, it's not many. Most of the student, I think 100% student coming through the door, not the window, or not the wall. So all students coming. Then either this way or this way sit. Right? So if we actually draw the lane of such a trajectory, you can easily find 2 or 3 the pattern. So if something happened, unusual thing, like the robbery or something, the terrorist coming, then the jumping on the desk is out of such a pattern, so called outlier. So we can outline. So that was my 20 years ago dissertation topic, but unfortunately it's not commercialized. I'm still use the surveillance camera sold by the Costco, which is just alarm, whatever the changes. Okay, so that is type of data set. So when you select the database project, a data mining project, think about what type of data. So mostly alphanumeric data, but some of the students may be interested in the social media data. At that time, you need to understand such a graph data structure and so on. If you are interested in the video, so you should be familiar with the pixel and such a color value is 3-dimensional array and something like that. Also, video is also sequence. So you can be aggressive to select such a thing. Like the sequential data and or time series data. Also, you can focus on the traditional. Also, you can select the multimedia data. Good news is using such a multimedia data in Python, a lot of package. So you don't have to spend a lot of time to implement how to process the image. Instead, you can just use the existing library. So, okay. So we are going to consider each data item as a data object. So data object is a different name is entity in the ER modeling if you already took the database course. So then they have a number of attributes. So such an attribute, analyzed attribute, is very important in the data mining. Okay. So attribute sometimes is a different name. The dimension usually used for the numeric data, okay? But not always. The feature, the data mining likes such a feature, machine learning use the feature instead of attribute, and variable, it doesn't matter, okay? Such an attribute has the same data type that we discussed here. Any of them will be the data type and the nominal, binary, and the numeric. So I will quickly move to so nominal data is a category. So category used a lot in traditional database in the database system with the binary. So binary is a 0, 1. So actually binary problem looks very simple, right? Either yes or no. It's at least the random guess is 50%, but actually it's not that easy. So a lot of problem in data mining and the machine learning is a binary problem. Cancer. whether cancer or not. Yes or no? But problem, first positive will be huge impact. So is cancer, I'm sorry, but the diagnosis as the not cancer, so the negative, it will be problem for his life, right? So depending on the what is the problem, such a binary problem is not the simple. Even think about the stock market, gain or loss, it's a binary problem. And a lot of image processing is also the binary problem. So I'll show you the lane detection. In the lane detection, we try to find the lane or not. It's a binary image we are using actually in this the example. So if that is symmetric, it's better. But a lot of the data is the skewed data, unbalanced data. So when you are dealing with the unbalanced data, so you should be careful. Also, that is that affect the different technique for the evaluation. So evaluation. Think about so cancer. What kind of cancer? Lung cancer is one of the 100,000 cases, for example. So when you project diagnosis always negative, then 99.9999 is accurate. Even though I'm not using any algorithm, so just negative always is 99.99999 accurate. So do you take this algorithm model? So when you evaluate, you need to think about how much support and at the time you can use the precision and record. We will see such a precision and record during the exercise lab. We will see. Okay. Also ordinal data. So it's ordered. You can see the small, medium, large, or sometimes it can be coded like the 0, 1, 2. So they have the, so when you process analyze, so it's a different such ordinal data or nominal data. Nominal data, there is no order. Even though both of them are category, but this category has the order, small, medium, large. So you need to consider when you analyze the data such as ordinal or nominal. Some of them, that will be discussed in the pre-processing of the data. Sometimes you may not handle such the interval, for example. So interval can be changed into the such ordinal or nominal data, categorical data. You can pre-process, then apply any algorithm, data mining algorithm or machine learning algorithm. It works much better. Okay, so at that time you can use the pre-processing before you apply the algorithm. This is the most important part of the number, so whether discrete or continuous the attribute. We mostly use discrete because computer can process only discrete. Okay, so because of that you probably took the discrete math. Instead of the integral, you can use summation. So that is a discrete. So how can we deal with the continuous data? How can we handle? For example, audio. Audio is, as you know, is a wave. Right? It's a wave frequency. So it's here there's something frequency, but we cannot store the data as it is. Instead, we need to make it discrete, which is called the quantization. We are going to cut sampling, then assign the value. This is called the quantization. Then this value will be saved. The precise will be close to the original, the acoustic, the analog wave. Okay, but it will consume a lot of processing as well as the space. So proper, because unfortunately, anyway, the human ear actually the range of the wave is narrow. We cannot hear the ultrasound. We cannot hear very low sound. Unlike the animal. The hearing the power range is much wider than the human being. So the ear can take only this much. So we can actually ignore some part. Even our hearing system is not very precise, not powerful. So this, the quantization level, this one, not much different. No difference. So we can use such a thing to make that discrete. So if you are interested in the audio processing in your project, you should consider such a thing. I will introduce a couple of well-known such audio processing algorithm today also, like the Fourier transform. French, it's a Fourier. In American English, Fourier, something weird. So. Okay, so basics. So one of my friends said, when I studied the English, after I moved to the United States, English is one of the easiest languages. So comparing to the other. Do you agree?
No.
The reason is that the English does not follow original pronunciation first. The French, German, so in English, we actually pronounce as it is, right? If you think about the pronunciation, most of the word is from the language, French, German, Italian, and so on. The English actually doesn't follow the original pronunciation. Just read as it is, and they simplify a lot. So that is the reason one of the students from linguistic department said, my friend, so English is one of the easiest languages. Then I agreed when I studied the Chinese several years ago, because every winter I'm teaching the CS 101 and 102 in China. And so I try to learn Chinese. Still, I don't understand difference between the tone. There are different tones in Chinese. So even same word, but same pronunciation, but different tone. So it's I really hate any language, including my mother tongue. One of the worst subject in my high school. Okay, so our goal of the data analytics, including statistics and the mathematics and the data analytics, we'd like to understand data set, data. This is our goal, understanding. To understand the data, we need to characterize. So characterization is very important. So this is the classical, the traditional way of such a characterization. So, for example, to understand the data, like the midterm, we had a midterm, the two sections, section 1 and section 2, and how can I, the judge, understand the performance of the group section. Using only one number, so average, who is better. And also sometimes, so when you apply the college admission, or you probably apply the graduate admission, so you submit the transcript. Then admission office would like to see GPA. It's just one number, it's but most important. Because that GPA characterizes your performance last the 10 years, 20 years. Okay? So, if we have such the measurement of the characteristic of the data, it will be actually done if you can find such a. As you can see, the mean cannot represent everything. If GPA can represent entire my life, I cannot be here because my GPA is very low. I'm not sure whether I mentioned my GPA in my junior of college was 0.76. You don't believe? It really happened. Because of my mom always said the God punished me to teach something in English because I didn't study. So this is one of the statistical way to represent the data set. But all the mean. I don't have to explain what is the mean, median, and mode, but all of them are actually the one value. Right? It's called the central tendency. Okay. Instead of the group of data, we try to find the one. So the value to represent, to characterize the data set is a central tendency. Okay. I know. So median is not very popular out of the United States, but the United States, the median is used a lot. So median is order. So calculating median is not that simple. You need to sort all the data and count the middle value. Okay? So actually it's much complicated than the mean and the mode. Sometimes we call the, you don't have to worry about too much, but skewed data. So when you have the skewed data, it's unbalanced. It's not symmetric. You should be careful when you deal with such unbalanced data. The binary data is the same thing, symmetric. It's a half and half, the probability, but just like this example. So even though I just get all the case, the positive, negative, this is still the 99.9999 true. So you should be careful. So when you deal with the skewed data. Okay. So then for the how data, one of the problem of the mean is the 1, 1, 1 is the same as minus 1, 0, 0, 0, and the 0 and the 100. So mean value is the same 0, but their distribution characteristics are different. So to understand such a distribution, which is called the dispersion. So like the standard deviation and variance and the other things. So and this is a popular approach in statistics. So if you are in the business program, you learn the statistical tools pass or the nowadays art. They provide a lot of such including the plot and the graph. But we are going. You should know in data mining class variance, covariance, and correlation. So last time mentioned about I introduced correlation, covariance, and this is variance is for one attribute case. Okay. So if non-computer science, the paper or dissertation like the education, business, art, or art and science, they use a lot of such the technique in the paper and the presentation, because this is the one of the nice way to represent the characteristic of the data set. So if you apply the new pedagogical approach in the class, like I'm not going to use the PowerPoint, instead I'm going to use only the pen, then how do you prove the performance of your new technique? Then we should define the group data set is a number of students. At the time, then using this kind of the analysis like the probability evaluation. So based on the exam and so on, then you can present your data. Then you can show that this is better or not, something like that. I already mentioned about the normal distribution like this. Then we can actually display the characteristic of the data using box plot and so on. You can forget all the other except this one. The histogram is used a lot. So histogram, what is a histogram?
Number of frequency for every event.
So you know that it's
We
kind
have
of,
samples, we have a number of frequencies.
yeah.
How much,
That is the frequency of the each. Like think about the elementary school. Surprisingly, during the elementary school, we learned a lot, right? So every day, if you come to the class, you mark that this is the sunny, and this is cloud, this is rainy, this is the snow. Then put something sticker like this. And rainy and snow like this. So in the February, we can see the something characteristic of the February. Okay, that's different from the August probably. So if we use the frequency of the something attribute data, okay, then we can easily understand this data set. It's better than mean value and better than the dispersion. So this is called the histogram. The image used a lot. Image used this histogram a lot. So then if you have the similar the images, probably they're red, green, blue. Extreme case we have three color. There, the frequency of the RGB may be very similar, not vice versa. Okay, inverse is not true, but this is if the two images are same or similar, this will be the very similar histogram. So this is the used a lot in the data analytics. So to understand, okay. So it's actually from the statistics, the histogram. It's a bar graph, but based on the frequency. This is very important. Any machine learning, any data mining, any AI, the algorithm actually based on the frequency. The problem is how to keep that frequency, how to catch. So like sometimes the neural network keep such a frequency in the number of the node. Okay. Also, in the histogram, we keep such a frequency using bar graph. So, if something, the event is not happen a lot, it will be very hard to find the pattern. So sometimes the machine learning is called the pattern recognition. That is much more similar to the data mining. So machine learning itself is not very close to the semantic. So our goal of the data mining is to find the meaningful information, which is not easy to get. Okay? To do that, we are using machine learning a lot. But machine learning is a training system to keep the frequency. So if we don't have the frequent something event, that is the pattern. So if we can find such a pattern, like the certain threshold value, this is called the threshold. So something over the given the number, then we will take this one. So that is the recognition. Then it's close to the purpose of the data mining. So histogram is very important. If you are dealing with images, so you definitely understand the histogram. But histogram has a problem, even though same histogram does not mean the same, the meaning. Okay. So QQ plot is not used a lot. But we have used this. We will see today while we are discussing on the PC. This attribute and this attribute are correlated, positively correlated and negatively correlated. Okay. But this is the uncorrelated, the scatter, just a scatter. This is very hard to say the related because it's wide the margin. Okay, that is the overview, quick overview of the data. Even understanding. So statistics in the business school education, they use this kind of technique. Nowadays, even they apply the machine learning technique for their research and so on. But this basic statistical description is still important. So if you are interested in the statistical approach in your project, also not only Python, also you can use the R programming. So a couple of years ago, I used the R programming when I didn't know how to use the Python. So, but R programming is the almost same as SPARS, SPSS. It's a very expensive statistical tool, but R has all the functionality and the powerful, and you can find most of the code package. So if you are interested in the, I think the Kaggle also support the R, right? Kaggle also support the R. YouTube time.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space, with a bit of technical assistance from the crew. So, here we go. First, an axis for health. Life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, 400, 4,000.
So they are using World Bank data set. Also, you can find easily World Bank data set that shows each country, their wealth and population for along the time.
Now, I'm going to show you the world 200 years
This is
ago.
one of the popular data set for data analytics data.
Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubbles show the size of the population.
So in dynamic, such an interactive graph shows a lot of big. At the same time, we can easily understand the meaning of what he is
The
suggesting.
Netherlands was slightly better off, but not much.
This is 1810.
Now, I start the world. The Industrial Revolution makes countries in Europe and elsewhere
So Europe started
move away from the rest.
develop
Colonized
first
countries in
and
Asia
the bounce
and
up,
Africa are stuck down there.
unlike the red
And
and blue.
eventually, the Western countries get healthier and healthier.
So their population is also growing up, but more importantly, their income and lifespan. They are, you can see the
Now I speed up
related.
to the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards
Probably
greater
this
Western
is
health.
China and
Japan
India,
some others try to follow,
but
most countries
it
stay
will
down
be
here.
bounced back.
Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil.
So
but still
surprising.
short lives.
After World War
And the
II,
Asian
Japan
giants,
is the leading
China,
country
India,
except
Pakistan,
the West.
Bangladesh, and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier and healthier. And in the 1970s, then countries in Asia and Latin America started to catch up with the Western countries.
You can
They
see
became
the
the emerging
India,
economies.
China.
Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV.
And
now
you can see the
we can
next
see the world
opportunity
today in
probably
the most up-to-date
Africa. That is one of the reasons Chinese government
Most
is
people today
fund a
live
lot
in
of money, really a lot of money
at
to
same
the
time. We
African
get the
country.
best of countries
Really a
and
lot.
the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages, but I can split them. Take China, I can split it into provinces. There goes Shanghai.
That's only Shanghai,
It does the same
like
work,
the
and that does it,
California
actually.
in United
And
States.
there is the Pureland province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in
But
Africa.
after 10 years right now, it
And
will be
yet,
much
despite the
further
enormous
and the
disparities
bigger.
today, we have
probably.
seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology and peace, it's fully possible that everyone can make it to the healthy, wealthy corner.
So,
Well, what you just seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
so what is the point of this video? There's two classical answers. So what I learned from the video is going to Africa if you want to make the money. That's what I'm thinking. But it's a visualization. You can easily understand huge. If you go to the data bank, data says just number, a lot of attribute and but. So from the visualization, it's one of the best visualization last 10 years for me. So we can easily understand the point of what he's saying. So that's the power of visualization. Even maybe possible to predict what's going on the next decade. Okay, if you can see, track the last the several decades and what about the next decade? So the moving, the income, and so on. So that is the visual. What is a visualization? So we try to use the graphical, the graphical tool to display the data. Nowadays, it's not just the displaying the data using the graphic, but also it can be used for the data analytics. So visualization is one of the important the analyzed data. So there are several examples of the visualization. The Google provide the Google Viz, so you can see. I think you already know. This is a similar. So you can make the dynamic graph for the data, very similar as what we have seen before. Okay. So this is another example of using the visualization tool. So there are different categories of the visualization. I'm not going to introduce. You can find this easily. And such a visualization can be used for the research and in the thermodynamics or the aerodynamics. So visualization is kind of the what is that? A simulation. Okay. So such a thermodynamics or the aerodynamics, they try to model so mathematically, but they want to convince. They want to make sure whether their model is good or not. At that time, we can use a simulation using the visualization and so on. So there are different techniques, but it's not critical right now. This is old-fashioned the visualization. We can use such a different phase. Then we can see the pattern of this is a census data. So like so this group is similar and this group is similar. Each one has a different meaning. So using icon. Okay. Also, you can use such a different the icon to represent the meaning. Then, if we can find the pattern, that's done. Okay. It's one of the popular text, the visualization word cloud. Then we can see easily. A lot of the research use something. So this is from the title of faculty research day. You can see the education and engineering are doing a lot for the simulation and detection. So in the research. I'm going to skip some of the part. So nowadays, the visualization, even including in your project, think about after you finish all the project, if you cannot present your work nicely, fancy, so nobody recognizes your work. So at the time, you can use such a visualization tool, not only just the graph, the old-fashioned graph, but also a lot of the research used nowadays map. So if you are using the Google map or something, the Google map is most popular, but you need to pay. So as far as I know nowadays, so if you know the longitude and latitude, you can plot. So you can easily visualize your geographical data. Okay, and this is the network using graph. So I'm not sure. This is probably the political, something political, the Democratic and Republican, something like that. And also, along the time you can represent. So you can see that something happened here. It has the peak like this. And science, the scientific problem use a lot of such a visualization. Okay, so this is wind, and also nowadays we use the visualization to represent a very complicated problem. Okay, in one page. So you may see the infographic. This is called the infographic. So information and graphic. This is one of the traditional infographic, the visualization. Napoleon's march to Moscow, 1869. So width represent number of soldiers. And along the time, so it shows the temperature and the moving the group of the army going to different one, and finally it has one sixth and something like that. So it shows. So it is after the Napoleon's march to the Moscow. I cannot remember, but one of the person visualized the result of that. Okay, and from the one graph we can, it has not only just X and Y, two attributes, but it shows the many attributes at one time. And also you can buy from this one. So every year, actually, this company send the sample of the huge printed map and paying something. This is another example of using the visualization. It's a cholera outbreak. So this is Paris. I cannot remember. So Paris, and anyway, one of the city in Europe, it outbreak of cholera. So they cannot find the reason. So then, after they plot, you can see that something happened a lot. So each dot represents one death. Okay, so you can see over here and over here and over here. Then that's exactly match as the web. So they realize that the cholera is from the water. So they try to clean and something do for the water. Okay? So they mark the well and something like that. So that is how to use the infographic visualization to solve the real problem, social problem. This is interesting. We can actually visualize the writing style. So I don't know exactly. So for example, if the certain word is the positive word used, then the move right, or the depressed word, negative word down, and something like that. Then we can actually characterize the writing style using the visualization. Then also we can find the similar, the pattern, mood of the writing using the visualization. This is another example of the power of the visualization. So from here we cannot find 8, but if we visualize, easily find. That is the idea, a very, very fundamental idea of the visualization. So please think about how to visualize your data and your result during the project, the project also. And, so we have seen the what is the data and also how to represent such a data using the visualization. The last thing is what we want to do is when we have a record or item, or a number of attributes, can we compare whether they are similar or not? This is the most important part of the classical, old-fashioned, or sometimes it's called the shared, the shallow learning comparing to the deep learning. So we try to find the similarity or dissimilarity of each data item. Okay, how much? If we have only one attribute number, we can use Euclidean distance. So distance measure. Okay, subtract and the abstract. Then we can calculate how much difference between the number. Like the 0, 0, 0, they are all the same. This one is 100 difference. If this is 100 difference, we can use such a distance measure. However, if we have the non-numeric data, even though we have numeric data, depending on the type of numeric data, we cannot use such a Euclidean distance. So overall, we will record that is the similarity or dissimilarity. They are different. The dissimilarity means it's the distance, how much far we are going to focus. Similarity is how much similar. So it has a range, similarity, usually 0 to 1. 1 means identical, it's the same. 0, totally different. However, dissimilarity, how much different? Totally different. How much totally different? We don't know. So it's usually infinity, like the distance. So proximity, refer to both of them. Okay. So when we have the data matrix, so we can represent the one record number of the attribute, another record number of. Then we can build the n by the p, the matrix. So we can calculate apply the operation of the matrix. So this is similar to matrix. So we can calculate the attribute by attribute. So when we have the two data item for p number of attributes, so we can calculate attribute by attribute distance. But that doesn't mean the overall dissimilarity or similarity measure of the record by record. So to address that one, there are different the method. So we can count number of same attribute among data one has A0, A1, A2. There are two items, also attribute. So we will check the attribute by attribute whether they are same one or same one or same one. They count. If all of them are same, 1. Otherwise 0, something like that. Also, let's check the next one. So for in case it's a asymmetric skew data, it may be different. So it's not the balance. So when we measure the proximity, so general the proximity is, this is not the critical. Let's take a look at the example. So this is the number of attributes. We have the 3 data. So we can consider in this case, the symmetric attribute. Okay. So gender, if Jack and Mary, how many? 1, 2. Let's see. I didn't check the binary variable, the approximate. Let me check during the break, then we'll let you know. So this is not the popular one. Okay. And most popular one in the numeric data is Minkowski distance is a part of Euclidean distance is a part of the Minkowski distance depending on the h. So for example, if h is 2, that is a Euclidean distance square and the root. Okay, and if h is 1, Manhattan distance is like if you go to Manhattan, so like this is a street and avenue, you cannot go to diagonal. So you need to go this way, so we can calculate the distance based on how many blocks you are going to move. So this is the Manhattan distance. And if we send h to the infinity, that is the supremum. Supremum is a limit. We can limit the distance. Okay, this is an example of the Minkowski distance. So most popular one is a Euclidean. Then one of the popular approach of a number of attributes is a weighted Euclidean distance. The weighted Euclidean distance is, in this case, each attribute has the same weight, but you can give the W0, W1, and P, the weight. So such a weight, sum of the weight is 1. So we can give the more higher weight for the important attribute. So that is the weighted Euclidean distance. So mostly popular use the distance measure. So ordinal cosine similarity is popular for especially the document. So this is very important in the search, web search. So when you search what's going on when you search the Google? So keyword. Then behind when you submit the keyword like the university, Bridgeport. So Google try to find the document, a number of documents that include the keyword. So however, Google will not search all the document, right? It will take a really long time because it's billions of web pages. Instead, they are using the index. Okay, so using index, what is the index? So by keyword, number of words, Bridgeport and university, they have a number of documents. Already search the document for the keyword, then return the keyword. At that time, when you make such an index of the document, sometimes we need to compare whether documents are similar or not. At that time, we are going to use the cosine similarity. Cosine similarity is based on a number of keywords, which each keyword is represented by the attribute. Attribute 1, attribute 2. So team is the first attribute, coaching is the second attribute, and so on. So for example, if the team is 5 times appear the document 1, we try to find a similar document 1. Then if another document has a 5 or 6, it's very similar. So that is the idea of that. And for along the attribute, a number of attributes. So this is the product. So which means multiply. If none of that is a 0, 0 or the 0 something, that will be 0, and so on. Then the D1 is if we consider this one is the vector, and the vector is the node of the vector. It's the kind of the power or weight of the document weight. So this is called the cosine similarity. Cosine similarity used a lot for such a document. And so we can calculate such a similarity, D1 and D2. So it's a frequency of each attribute, each word. So we can do product by element, then the norm of D1, the vector. So this is the square root of the square and the square root. Sum of square, then square root. Then, for example, the D1 and D2 is the 0.94. The reason why it's called the cosine the similarity is actually this idea is if we represent the vector as the geographic, so it's the cosine distance, same as the cosine distance. Okay. That's the end of the unknowing about the data. Okay, so this chapter may help you to understand the data itself when you are doing your project as well as other topics. So after a short break, we will continue the pre-processing, including the PC.